Okay, so this is the next lecture. It will be about Optimism protocol and deep dive. We already had an intro presentation about what optimism is, what are the principles, and how it works. But now we will dive deeper into the protocol, the main components, the logic that optimism is using in order to scale Ethereum and yeah, how it all works together. So first of all, what is optimism? I gave similar definition in the first lecture, but I will go through it again. It is an optimistic rollup. It uses the mechanism, the consensus mechanism of the underlying blockchain, the parent chain. In this case, it could be proof of work or proof of stake. And the last thing, which is super important in this for optimism in particular, is that its parent chain is Ethereum. So optimism, if we can summarize, is an optimistic rollup that is, and its parent chain is Ethereum. Um, the first thing that is important for optimism in order to understand how it works is how are the blocks stored. So you can see that layer 2 blocks are saved to the Ethereum blockchain using a non-contract address. What this means? On Optimism chain, we have blocks and we have transactions and we have blocks, and they are happening inside the state, the state management of Optimism. But from time to time, there are something like checkpoints or let's say milestones that are happening, and all this information is stored on the Ethereum main chain, the layer one. Um, yeah, they're using a non-contract address in order to store this information. And lately, a lot of protocols are using bi binary large objects, in the other words, blobs. And it is used non-contract address because it's cheaper to store it on the Ethereum layer 1 that way. Um, Blocks that are written in layer 1 are in compressed format in order to reduce costs, because when you send transactions to Ethereum mainnet, it's expensive. So it's important to optimize the space and to optimize the size of the transactions. And basically writing to this layer 1, in our case Ethereum, is basically one of the the major cost that is have to be paid from the Optimism mainnet transactions. So the transactions that are happening on Optimism are paying some fees, and part of these fees go to the miners, but the major part goes for covering the transaction fees for broadcasting transactions on Ethereum. What about the block production? It is managed by a single party at the moment. It is called the sequencer. So Optimism Collective or some of the Optimism organizations are managing this sequencer, the community. So it is a crucial part of the protocol. At the moment, it's, like I mentioned, managed by uh, the Optimism developers, but in the future, the idea is that we have multiple sequencers, so that way we can decentralize the sequencer and the responsibility, and also make it more robust. Um, the main I mean, it is important that the sequencer is providing transaction confirmation and state updates. Also, the sequencer is constructing and executing layer 2 blocks. So this is another important part that the sequencer is doing. And it's also submitting user transactions to layer 1. So the sequencer is a crucial part. It's like the core part of the protocol. it submits transactions to layer 1. It is making the correct order. And there are some other modules that are making the batching and the, let's say, make it to take less space, but the sequencer is, yeah, basically submitting the transactions, constructing and executing layer 2 blocks. So it's one of the most important modules in Optimism. About the block execution, the block execution is happening in Optimism itself. So it is using it is CVM compatible, and it basically operates on multiple nodes. So this execution layer is operating on these nodes, and they can update each other. Basically, it's the same like having nodes on layer 1. Like when you have a new soft fork or new update which is happening on the network, all the nodes are updating each other. The same thing is happening in Optimism. It is peer-to-peer network and it has multiple nodes. And the other thing is that the roll-up node is deriving layer 2 blocks from layer 1. So when we have deposits that are happening on layer 1 or some other messages coming from layer 1, they are derived and layer 2 blocks are produced. Another critical part, which is part of the protocol, is bridging tokens, the Optimism bridge. The idea is that the bridge is allowing you to move funds from layer 1 to layer 2 and vice versa. In order to do that, there are a set of smart contracts that are listening for events and messages that are happening on layer 1, and then the Optimism nodes on layer 2 are doing the corresponding operation. And yeah, we have the other way around. When we have a withdrawal operation, it is happening on it is basically a multiple step process, so we'll cover it in more details in the next slides. But yeah, everything is based on messages, smart contracts on layer 1 and layer 2 that are communicating with one another. Transaction that is basically moving funds from layer 1 to layer 2 is called deposit according to the Optimism protocol, and withdrawals in reverse are the term that is used when you move tokens from Optimism mainnet to Ethereum. Fault proofs. This is an optimistic roll-up state commitments that are published on layer 1 and in this case on Ethereum. And without any direct proof, the transactions are accepted. But after that, there is a challenge window. And inside this challenge window, which is usually 7 days, at the moment it is 7 days, at the moment, a multisig that is controlled by Optimism community can raise a challenge in order to revert some of the transactions. But in the future, anyone can raise a dispute and claim that some of the transactions are invalid and they could be reverted. So that is why it is called optimistic rollup, because the state commitments and everything is directly published on Ethereum. So it makes it faster because you assume that everything is correct. But after that, if there is some inconsistency or some malicious transactions, they could be challenged and they could be reverted. They are reverted only on Optimism site, but the commitments are not deleted from the layer 1 from the Ethereum network. This is also an important addition. You can see how the deposit flow works. So if we look at this, we have a layer 1 user contract. So if I try to move my ETH from Ethereum network to Optimism, where Ethereum is layer 1 and layer 2 is Optimism, I should do the following thing. I should use the layer 1 contract, deposit contract, bridge contract, whatever it is named. So I have to deposit ETH here. Then it will send a message to the Optimism portal. Optimism portal will will create a deposit transaction, and it will broadcast an event. And then when the event is broadcasted, all of these things are still happening on layer 1. But when the event is broadcasted, the Optimism nodes will detect the event. They will create a user deposit transaction, and basically what is happening, I'm walking some ETH here in layer 1, and then is created a deposit transaction that is creating an ETH token on layer 2, and I'll receive it on my address. So the parameters that are passed in the deposit flow functions are basically the target. This is the address where I want to receive my ETH on second layer on Optimism. It is a message that has some information about the transaction, and there is some minimum gas limit. This is the computation units that will be used for the transaction on layer 2. This is important because it is basically protecting the protocol from some attacks that are trying to overwhelm the network. So it is a protection for that, DDoS attacks. And yeah, basically you should put the right parameter here, otherwise the transaction can fail. Of course, beside these parameters, there are also the default uh, not parameters, but default pieces which are in an Ethereum transaction, which is a to address value, the amount that I'm going to deposit, and yeah, some other default parameters. This is how the transaction flow works. It heavily depends on the batcher and proposer. So we have transactions on layer 2, which are similar to transactions on layer 1. And what is happening is we have a transaction. It is going through the op-get, which has the old state. Then we have a new state. And the op proposer is sending a transaction to the layer 1 Ethereum. Or if there are multiple transactions, they are batched in order to save space. So the batcher is again broadcasting new transactions and new states to layer 1, and the batcher is compressing the transactions in batches, obviously. So when we have, let's say, 20 transactions, we don't send them one by one from the proposer, but we batch them, and then we send one transaction which is having the information of the state changes of these 20 transactions. And yeah, basically batcher and proposer are sending transactions here. And when the batcher sends a transaction, it is finalized as it is valid as soon as it is posted in a finalized block. And here there is some difference that it is valid after the 4th challenge period. So this is how the transaction states are. In the beginning, we have unsafe transactions that are already processed, but are still not written on the layer 1. Yeah, batcher fault could cause the transaction to fail. The second state is that the transaction is already safe, which means that the transaction has been broadcasted by the batcher and written to layer 1. However, they might be dropped because the layer 1 blocks could be reorganized at the level 1. And the finalized transaction is when the transactions are written to layer 1 and the layer 1 block that is holding the transaction is already major and old enough, and it will be extremely hard for the transaction to be organized. So basically these are the 3 states of the layer 2 transactions. First is unsafe, it's still not published to layer 1. The second state is safe transaction, it's already published on layer 1, but there is still some chance of reorganization. And the last state is finalized transaction. It is published on layer 1, and the block in which the state was published is already old enough to assume that it won't be changed. Here is the withdrawal flow. There are more details, but we'll keep it simplified. So the withdrawal flow is happening in three phases. First is that we're initializing a withdrawal transaction, which the user submits on layer 2, on the layer 2 smart contract. Then we have withdrawal proving transaction. This is a transaction that the user submits to layer 1 to prove that the withdrawal is legitimate. And yeah, it is based on some Merkle truths and Merkle roots and some other cryptographic magics. But basically, if everything is legitimate, then layer 2 to layer 1 passengers is stored on layer 2. And the last phase is withdraw finalizing transaction, in which the user submits on layer 1 after the fault challenge period has passed to actually run the transaction on layer 1. So what this means is that, yeah, withdrawing is kind of multiple step process. First, you have to send withdraw initiate transaction on layer 2. Then you have to send a withdraw proving transaction on layer 1. Then wait for the challenge period, which is usually 7 days. And after 7 days, you can submit a withdraw finalizing transaction. So this process usually it's slower because when you want to get out of layer 2, you have to pass all these checks and you have to wait significant time. And this is also, yeah, it's bad from user experience point of view, but it is a good practice from a security point of view. Then we have fault proofs. There are basically three ways of fault proofs. There is a fault proof program that is designed to, in deterministic way, to check if the transaction is correct or not. Then we have a fault proof virtual machine. It is another module which is again connected to the fault proof program, but it's separated. So the task of this module is to do a low-level instruction execution and check if the transactions will pass. And then we have a dispute game protocol. It is more flexible, and the idea is that you can create disputes and revert transactions. It is still not very clear how the dispute game protocol is working. It is still under development, and there are many things to be basically improved here. But yeah, these are the three fault-proof processes, and they are under active development. So now we have something which is important from decentralization and security point of view. What is happening if the sequencer have some outages? So let's look first of the case when the sequencer is totally not working, and basically there is a very serious outage. So what's happening? For example, user one wants to withdraw sends one transaction to Optimism portal that wants to be executed. User 2 is doing the same thing, but the sequencer is not working. Usually the sequencer is the one that is taking the transactions and then preparing them to be broadcasted to layer 1 or do something on layer 2. But in this case, the sequencer is not working. So these transactions are going to the Optimism portal. Then the Optimism portal is waiting for 24 hours. And after 24 hours, transaction 1 is included in the layer 2 automatically, and transaction 2 is included in layer 2 automatically. So, of course, if the sequencer is not working, it will be super significant delays. And yeah, you experience some delays. But at the end of the day, even if the sequencer is not working, the transactions on layer 2 could still be done and executed. throughout the Optimism portal. The other case, when the sequencer has some outage, but let's say the outage is only for 1 hour or few hours, this is what will happen. First, we have some outage in the sequencer, then user one is trying to send a transaction. It is going directly to Optimism portal. So usually if the sequencer doesn't come back, it will happen what happened in case one. The user one will wait for 24 hours, and then transaction will be included in layer 2. But in that case, the sequencer comes back after, let's say, 1 hour. It takes all the transactions from the Optimism portal, and then the transactions are automatically included in the sequencer and therefore in layer 2. So you can see that the system is still robust and decentralized enough that even if the sequencer is not working, and even though if we have only one sequencer, then the system can operate. So if the sequencer is completely out, then transactions will be executed with 24 hours delay. And if the sequencer comes back after some period of time, it will directly take the transactions from the Optimism portal contract and move them to layer 2 and confirm them. We can also mention the transaction fees. This is important for Optimism, but it is also applicable for Ethereum. So once you understand it, you'll know how the transaction fees are working. So there are basically three different kinds of fees. There is execution gas fee, there is base fee, and there is priority fee. So the execution gas fee is equal to the amount of gas used by the transaction multiplied by the gas price attached to the transaction. What this means in simple words, for example, you have a function that use addition of two numbers, and then you have some other operation that is using a store of this addition of two numbers and division of two numbers. So let's say that for example, addition of two numbers costs like 5 computing units. Division of two numbers costs 10 computing units. So now we have 15 computing units. Creating the transaction, invoking the transaction itself has a base fee, which is 21k computing units. So now we have 21k computing units from 15 computing units. So it is 21k and 15 computing units. So these computing units are in fact the gas. So it is called gas in Ethereum and in Optimism. So the computing time or computing units that you need in order to execute some mathematical operations or programmatic operations is measured in computing units that are called gas. So you can deterministically compute how much gas do you need, and then you have a gas price. This is the amount of Ethereum on top of the Optimism network that you want to pay for each transaction, for each computing unit. So if you have like 20 computing units, 20 gas, and you want to pay 0.001 ETH for each computing unit for each gas, then you have to multiply it. So I'm going to use 20 computing units and I'm going to pay 0.01 ETH for each gas use, so I will have to pay 0.020 ETH in total ETH I will have to pay. So the next thing is the base fee. The base fee is the minimum price per unit of gas that should be paid. So as I mentioned, there is gas price. So the base fee is the minimum gas price that is going to be paid, but you can put more if you want, and that way you can guarantee that the transaction will pass. You shouldn't put the base fee under the minimum that is required at the moment. And then we have a priority fee. This is a extra gas price that we are paying per computation that can guarantee that our transaction will pass faster. So in other words, we can pay more fee in order to broadcast and execute our transaction faster. So the whole thing with the transaction confirmation and adding it into the block is something like a open market and auction. So the miners are seeing the different transactions and they can see that this transaction was broadcasted first, but the rewards that could be earned from this transaction is $5. And there is someone else who broadcasted a transaction at relatively the same time, but a little bit later, but it still could be included in that block. And this second transaction is paying like $20 reward. So the miners will decide to include first the transaction that will pay them $20 in reward rather than the other one. So this is how you can manipulate how much you are paying with this priority fee and can try to broadcast and include your transaction faster than the other transaction if they pay less. There are some other functionalities inside the bridge contract that is used in Optimism. So this is called the pausing functionality. So the whole idea is that the Optimism contract can have a specific guardian. So this Optimism portal contract is responsible for the bridging. As we discussed earlier, you can deposit funds from layer 1 to layer 2 using the bridge, which is using the Optimism portal, or you can withdraw funds again using the Optimism portal to take funds from layer 2 to layer 1. So there could be some security issues, and for example, it might be a bug or something could happen. So the Optimism portal has created a pausable functionality and has added a guardian address. And the idea of this guardian address is that if there is a bug or something happens, it has the authority to pause the bridge and it could prevent layer 2 to layer 1 transaction from being executed. So if a significant amount of funds are someone is willing to withdraw significant amount of funds from layer 2 to layer 1 from Optimism to Ethereum and there is some bug in the contract, the Optimism portal can basically execute this pause functionality if the guardian address is willing to do it, and that way the transactions will halt and no one will be able to withdraw funds from layer 2 to layer 1. And this is created in order to mitigate some risks and potentially save the protocol for some bugs that can arise. And overall, these are the main modules which are inside the Optimism protocol. They are allowing us to use this cool second layer solution, which is super fast and quick and uses much less transaction fees compared to layer 1. And at the moment, some of the best applications in the blockchain world are built on top of it. And yeah, these are the main modules, and it's pretty novel idea, architecture, and it's good idea to go through it deeper and learn how it works because other layer 2 solutions are using similar ideas, and this is basically the future of blockchain scalability. At least it looks like so at the current moment. And if you're interested and you want to get deeper into that, you can always go to Optimism docs and I'll paste the link here. So when you go to Optimism docs, you can basically check all the information that I shared. Most of it is gathered from here, but of course I've tried to simplify it and take only the most important points and make it more understandable, even though it's still hard. But yeah, you can go to the protocol section and basically check all the things that I mentioned about deposit, transaction, withdrawal, fault proofs, and so on. And do you have any extra questions or something that I wasn't able to explain clearly? Okay. If you don't have questions, I think that we'll have time for one more presentation, which will be much more, let's say, easier, but still super interesting. So if you want, we can continue with it quickly, and then I think that we are ready for today. Do you think that we can continue, or you need some rest? Okay. So the next one is related to DeFi ecosystem on Optimism and some of the most used protocols. For this presentation, I will switch from the slides to my browser because I want to show you some things. And yeah, the presentation is, as I said, Optimism ecosystem. And if I have to be more concrete, it's not only about Optimism ecosystem, but Optimism ecosystem related to DeFi. Uh, the most used protocols, the more liquid protocols, and some interesting facts and applications that you can try yourself after the course. So at the moment, Optimism ecosystem is one of the biggest in terms of total value worked. It is like 830 million at the moment worked on Optimism ecosystem, which makes it one of the best layer 2 solutions. Um, Most of the value that is worked inside Optimism is used for DeFi. And what is DeFi? DeFi is a new term that came out a few years ago. It is referring to decentralized finance. It is an emergent technology that is based on the classical financial uh, ideas and applications, but it is implemented on top of the blockchain. So you can think of banks, insurance, trading protocols, prediction markets. All of these, we already have it in the Web2 world, like in the regular web applications. We had it before, even we had internet. And now some developers are trying to move this to blockchain, make it more permissionless, more open, more transparent. And yeah, more scalable, I could say. So, for example, one of the most famous DeFi protocols on Optimism is Aave V3. Uh, Aave is a lending protocol where you can go and lend your funds and take some yield because of that, or you can also borrow funds. So, for example, you can put some Ethereum or Optimism tokens as a to lend them, and after that borrow some other tokens that you want to use. So if we come here, for example, I'll try to open Aave on Optimism. If you come here, you can see at the moment the total market cap or the total funds that are available here is $238 million. And what I can do is, for example, if I put here my Ethereum uh, available ETH on Optimism, I can I can earn some 2.28% yield on top of it yearly. So the amount of funds that I deposit, I can make some profit out of it. It is like a bank deposit, but as you see, the percentage are much better. And this is for ETH. If we go back to the markets and, for example, we check what's happening with USD coin, which is, like I mentioned, a stable coin, which is topped with BTC, and the price of USD should be, in theory, all the time $1, and most of the time it was. So if I deposit USD coin in this protocol and I just let it stay here, at the end of the year with the current rates, I will earn 9.68% on top of it. This is almost 10%, which is a huge number compared to what the current banks can offer to us. At the moment, the total supply that is worked here is $27 million. So some other people already did that. They put their USD coin into this, just deposit it and stay, and let the, like it said, let their money work for them. So at the end of the year, they will take this profit out of it and they'll take their initial deposit. Another cool thing with Aave is that you don't have to work it for 1 year or 2 year or 5 years, like in a typical bank, but it is a very flexible period. Like there is no predefined period. I can lock my funds today, and if I need them tomorrow or after 1 month, I can just go and withdraw them. I'm not uh, put in a situation where I lock my funds and I cannot use them for the next 1 year. So it gives, first of all, higher yield, and it gives you more flexibility. Like you can withdraw your funds whenever you want. So I think in this particular case, it is much better than a typical bank deposit. Another token, for example, is Tether, which is another stable coin, same as, I mean, DAI is also stable coin, and they can return you even higher percentage. For DAI, it's like 12%, for Tether is 11%. So, in my opinion, these are some very good percentages of profit that you can make only by supplying your tokens here, and some other traders can use it for liquidity. But again, they cannot take the money and run away because everything is backed by collaterals. So far, this protocol has been operating for 6 years, and there wasn't a significant hacks, and no one has lost their funds. But we can never know. There are risks, and yeah, it could happen some bugs, so you never know. But it's the same with the banks, as we saw. And sorry, let me make some corrections. So the supply APY, so the money that you can make out of supplying, for USD is 6% and for Tether is 8%. I said 11, but 11 is the percentage that the borrowers are paying. So you can see the difference. If I supply, I take out of it 8%, but if someone tried to borrow, they should pay 12%. So there is difference. It's, yeah, some of this money stay in the protocol, or they're using them for some extra expenses related to the protocol. But still 8% is like enormous compared to the current banking system and the percentages that they're proposing. I think the maximum is like 2%, but I'm not even sure about that. Okay, so the next protocol that I'm going to show you is Uniswap. I already mentioned it. So it's a super simple swap widget that is based on automated market making formulas and ideas. It was again designed around 2018, and from there it is maybe the most liquid market for tokens. The whole idea is that you can swap one token for some other token. It will automatically give you the rate, and there is a huge amount of liquidity. So this is solving the problem with supply and demand in this kind of markets. Usually when you have an exchange, there is some people that are selling, some people that are buying, and you should match them. But here there are liquidity pools. So some people just, or agents, provided liquidity into the protocol, and after that some other users or agent can come and swap against it. So everything is automated, algorithmic, and there is much more liquidity than a typical market. And as I showed you earlier, there is like 1.2 billion volume only for yesterday. And for its life being, I guess that trillions of dollars have been moved throughout this widget. And the smart contracts behind it, of course, because the widget itself is nothing if there are no smart contracts that are empowering it. Um, Another protocol which is similar to Uniswap is Velodrome. It is targeting more specifically optimism, but the idea is similar to Uniswap, but you have some other things as well. You can have a swap functionality. You have some votings. Maybe it is voting for the Velodrome protocol, not sure. But yeah, you can see similar ideas here. There are liquidity pools, so you can provide liquidity, and after that you can earn some yield out of it. Another protocol that is slightly different is Superform. It is again having the same ideas, but it is mostly trying to show you what are the possible liquidity options that you have and where you can provide liquidity. So, for example, it is giving you an option to provide liquidity on exactly USDC protocol, exactly protocol. So if you provide liquidity on that, you can earn up to 10.6 APY per year. And the whole idea of this is to give you a dashboard where you can see the different options for providing liquidity. You can choose the best one. It's like an aggregator for these kind of things. And yeah, you can deposit whenever the profit is the best, but it's not important only the profit, but the total value locked. So you can see that here is 7 million, so it's not a lot, but it's relatively safe. But for example, in this protocol, there is only 65K, which means that the pool can be manipulated and it's not that safe. So if you're looking to earn some profits, take a look at the total value worked as well, because here is 10% on total value worked 7.46 million, and here you can make up to 16%, but the total value worked is only 10K. So it means that this protocol is not so stable and mature, and yeah, someone can hack it and you can lose all your funds, even though they say you can make 16%, maybe you can lose all of your funds in one day. So it doesn't matter if you can make 16%. It's better to have more stable protocol and earn a stable profit rather than risking everything. Some other interesting protocol is called another block. This time it is not related to financial stuffs, but it is, or maybe it is in some way. But the idea is that you can buy rights for music, like music rights. If there is someone who is a music creator or singer or whatever, you can invest in him or her, and after that you can have rights over the music that was created. And after that, if the music is sold to some I don't know movie or for some advertise or whatever, you are taking part of this profit that is generated out of the money that are paid. So if you're based in EU, you can apply and you can become an investor in music rights investor, which is cool. This is another usage of blockchain, which is not the typical one, but basically on chain you can buy the rights for some music, and when the music rights are sold again on chain, you can track everything. It's completely transparent and you can take your profit out of it permissionlessly. So it's a good idea in my opinion. Uh, there's another protocol which is Zonic, which is an NFT marketplace. This is something typical for blockchain. There are these kind of marketplaces for art. So you can see here different collections, and you can buy uh, arts or collectibles from different digital creators. Some of these uh, some of these collectibles went crazy. Like you can see that these are like $1, but for example, CryptoPunks or Bored Ape Yacht Club or whatever, these are the name of collections. One of their pieces could be up to $100K or $200K. So one piece of art, which is connected to this NFT, I mean blockchain smart contract, could skyrocket. So yeah, people are collectors, so they're into buying this kind of stuffs. But sometimes it's kind of unreasonable to give 100K only for some NFT. But the cool thing with the NFTs is that you can change the authenticity of this item. So if I buy it, I can see in the blockchain who created it and how many pieces do we have, and if this is an original art. For example, with the real art, sometimes some fraud is happening. So someone is selling a copy of Mona Lisa claiming that this is the original one, and you cannot really prove if it is the original one or not. Or yeah, basically copycats of some other famous images. And yeah, this problem is at least solved in the blockchain and NFTs because you can see who is the creator, who made the NFT, how much is the supply, and so on. And this is giving value to these items because they are more rare and you can verify from where they're coming. There is other protocols which are insurance ones. So here you can buy insurance. For example, I want to put some money in Aave and make 8% profit per year, but I'm not sure if someone can hack the protocol. So I can come to Cozy, and I'm not sure if they have protection for Aave, for example, but maybe, yeah, they have protection for some protocols here. And I can come here and buy insurance for Aave and pay like 2% out of the profit that I'm going to make. So rather than taking 8%, I'll pay 2% for insurance, so I'll make only 6. But if for some reason the protocol is hacked or something happens, then they'll recover my funds. So yeah, I can buy this extra insurance and I can still make some very solid profit. But it depends on you if you want to cut some of your profits to buy an insurance or you don't need an insurance. But it's cool that you still have this option because if you invest like, I don't know, $1,000, it's fine. But if you invest $100 million, maybe it's better to take a little bit less and pay for insurance rather than risking to lose all of it. Um, yeah, this Llama Pay is also a cool protocol. The idea is that you can streamline money payments like salaries. For example, if we come here, um, I guess it should be this one. So if you come here, for example, you have an employee that is working for you, and rather than giving him the salary once a month, you can create a money streaming. So, for example, I can say I want to deposit the monthly salary is $2,000, so I will deposit $2,000 and I'll stream it every day. So my employee will receive, if we have 20 working days and $2,000, basically every day we'll receive $100 to his bank account. We can even make it more fractured, like we can receive payment every minute. So rather than receiving $100 per day, the employee can receive, I don't know, let's say $10 per hour. And you can see on time when the funds are received. And these microtransactions won't cost you more money because if you do that in regular banking, you cannot do transactions every 1 hour or every day because it will cost you money for the transaction itself. But here you can do it. So yeah, that's a cool option to make microtransactions for different use cases. It could be used for example, video streaming. For example, I'm charging 1 cent for 1 second of my video. So if you want to look at only 1 minute video, you will pay only 60 cents. If you look at the whole video, which is 5 minutes, you pay $3 and stuff like that. And this could be automated. And the last thing that I want to show you is Thales protocol, which is a prediction market. So what is the idea here? You know about prediction markets, or let's say betting. You can go and bet on something, but here you can do it permissionlessly. So for example, it is like binary options. So you can say that the price of Bitcoin will be higher or lesser than 60K in 2 days. So if you prove yourself right, you take some like double the money that you put, and if you're wrong, they will take your the money that they will take your bet. So this is like some trading slash gambling protocol. They call it prediction market. So you can take part in such kind of protocols as well at your own risk. So I wouldn't do it. I'm not good in predictions and I'm not into gambling. But yeah, there are different options for different people that are looking for different kind of applications. So one last thing that is fun and something that is not possible in the real world without blockchain is pulled together protocol. So it is the so-called no lose lottery. So you can take part in this lottery and put your bet, but at the end of the day, all the bets are returned back to the users that put the bet, and some of them get extra reward as well. So how is that happening? I showed you this other protocol. So you can imagine that a lot of people put their bets. For example, the ticket is $100. So when they accumulate, let's say 1 million or $10 million, then this put together lottery protocol come to Aave, and they put all the Tether, for example, they are accepting payments in Tether, which is a stable coin. They put all the Tether in this protocol and lend it, and then they start generating some profit. And for example, after 1 week, they come here and withdraw all the Tether that they have deposited and the profit. And for example, it is 8% per year, but let's say for 1 month is 0.5% that was generated for 1 month. So for 1 week it will be like 2-3%, 0.2 0.3%. So 0.2% of 1 million is, let's say, some significant, not significant, but okay-ish amount, like $1,000. So they have generated $1,000, and then when the lottery is end, basically they return the money to the people that put the bets, and after that this small amount that was generated from the lending is basically a profit that is coming out of nowhere. I mean, it's coming from the bets, but it's a profit generated, so they're not taking the bets of the people, they are returning them, and after that the one who is the winner of the lottery is taking the profit that was generated from the yield. And that is how it works. But I don't think that this is possible in the real world. Like you take a lot of money, like from the national lottery, and then you cannot for 1 week move them to the bank, generate some profit, and take it back. It will be super hard to do. But here it's everything is automated. And that is about the DeFi ecosystem of Optimism. Of course, there are many other things. There are bridges, other lending protocols, and so on, but these are some of the famous ones. And yeah, I just wanted to show it to you to get the idea. So do you have any questions related to that? Okay. For tomorrow, it will be nice if you have MetaMask because we may need to use it for the smart contracts that we are going to write on Solidity. And for the smart contracts, we will use the Remix ID, which is basically an ID for developing of smart contracts, and we'll be able to come here, write some smart contracts, connect our MetaMask wallet, and then basically deploy the contract on Optimism network, like for real. It won't be only some tests, but we'll create some simple smart contracts and deploy it. And I think that this will be a useful preparation for the coursework. So yeah, I think that it will be nice